Open Google Maps and check the fastest route to your friend's place. Within seconds, you see live traffic updates, alternate routes, and even your estimated arrival time. It feels instant, but under the hood there's chaos. Raw signals from GPS devices, road sensors, and traffic feeds all streaming in at once. Before any of that reaches your screen, it has to be collected, cleaned, and organized. That invisible process of turning messy data into something useful, that's data engineering. At its heart, data engineering is about making raw data usable. On its own, data is noisy, inconsistent, and often incomplete. Businesses can't act on it directly, not if they want reliable insights or trustworthy AI models. Data engineering solves this by creating the systems that take in raw inputs, process them, and deliver clean, structured information that others can actually use. In short, it turns potential into something practical. Core functions of data engineering. This process usually unfolds in 3 steps that work together like a cycle. It begins with acquisition, when data first enters the system, whether it's from an app you tap on your phone, a stream of sensor readings, or a log of online transactions. That raw flow then goes through transformation. Here, inconsistencies are resolved, errors are fixed, and formats are standardized. It's the stage where NYC and New York City are recognized as the same place, or where time zones are aligned to avoid confusion. Finally, the refined data has to be stored and managed. Databases, warehouses, and data lakes keep it safe, organized, and ready for whatever comes next: analytics, dashboards, or machine learning models. On a small scale, this is manageable. But in the digital world, pipelines aren't handling thousands of records, they're handling billions. And that's where the wider ecosystem of data engineering comes in. Scaling up means bringing in more than just servers. It requires an environment of specialized tools working in harmony. Databases sit at the foundation. SQL for highly structured information, NoSQL for flexible, less predictable data. ETL and ELT workflows are the prep steps. ETL, which stands for extract, transform, load, means cleaning ingredients before storage. ELT stands for extract, load, transform. It means storing first and preparing later, common in cloud systems. Speaking of the cloud, platforms like AWS, Google Cloud, and Azure provide the flexibility to scale on demand. Within them, organizations decide how to store data. In warehouses, which prepare it neatly for fast queries, or in lakes, which hold vast amounts of raw data until needed. When the volume spikes into the truly massive, frameworks like Apache Spark take over, splitting tasks across many machines to process data in parallel, sometimes in real time. And underpinning it are all languages like Python and SQL, which ensure pipelines remain consistent and reproducible. This ecosystem makes large-scale data possible. But no matter how sophisticated the tools, they all depend on a simple principle. The quality of the output can only be as good as the quality of the input. That brings us to a key principle in data engineering: garbage in, garbage out. If the GPS signal itself is wrong, the app will faithfully process that incorrect information and send the driver there. The pipeline can't guess the right spot because the input was already flawed. Similarly, if a bank is working with incomplete customer records, its risk model might misclassify someone as safe or unsafe. Even though the calculations run perfectly, the starting point was broken, so the conclusion is unreliable. In short, data engineering ensures the system runs smoothly, but it can't fix bad raw inputs at the source. And this is why data engineering is so critical to the digital world we live in. It's the invisible foundation behind things we now expect to just work. It's what allows Google Maps to guide you through traffic, Netflix to recommend the shows you love, online stores to nudge you about items in your cart, and banks to stop fraud in its tracks.